Hello everyone, welcome back. Today I am here with one important topic in plant anatomy, that is anomalous secondary growth in plants. In this lecture I will discuss about the anomalous secondary growth and what are the various reasons for anomalous secondary growth. In our syllabus we have one dicot, that is Boerhaavia, which shows secondary growth, and one monocot, that is Dracaena, which shows anomalous secondary growth. So what are the various reasons for secondary growth in monocots as well as dicots? That we will discuss one by one. And our main focus is on the anomalous secondary growth in Boerhaavia stem and Dracaena stem. Let's start. Firstly, anomalous secondary growth. What is anomalous secondary growth? Anomalous means abnormal. So any deviation from normal secondary growth is considered as anomalous secondary growth. Deviation from normal secondary growth is known as anomalous secondary growth, and these deviations are due to, there are various reasons for this. First is irregular activity of vascular cambium. So अगर जो vascular cambium की activity है वो irregular है, that can also leads to this anomalous secondary growth. Then occurrence of successive cambia in the same stem. Again, this is the reason for deviation from normal secondary growth. Then occurrence of accessory vascular bundles, which are called as medullary vascular bundles when they are present in the pith region. For example, we have some families like Nyctaginaceae, Amranthaceae and Piperaceae, जिसमें जो vascular bundles होते हैं वो medullary region में पाए जाते हैं, means central region पाए जाते हैं. So there is anomaly or abnormality from the normal vascular bundles. So this animated photograph shows anomalous secondary growth in stems. This is the Nyctanthes stem, which shows cortical vascular bundles, presence of vascular bundles which are present in the cortex region, और ये inverted होते हैं, while this Boerhaavia stem shows the medullary vascular bundle that we were discussing. Next, occurrence of cortical vascular bundles. For example, in Calycanthus and Nyctanthes that I have discussed. So जो Nyctanthes है उसमें cortical vascular bundles present होते हैं, means cortex region में present होते हैं. This is the photograph which shows cortex branch, and its feature is it is rectangular in shape. ये rectangular shape की होती है this branch, and it shows the cortical vascular bundle. Then we have Begonia. This is the photograph which shows Begonia, and it's a section. It shows cortical vascular bundles. Then there are numerous vascular bundles which are present in some plants of family like Nymphaeaceae and Primulaceae. इसमें जो vascular bundles होते हैं वो numerous होते हैं. This is the photograph which shows Nymphea, and this is a section which shows Nymphea, and we can see here जो vascular bundles हैं वो distributed हैं throughout the plant tissue, और ये monocots की तरह feature है, which is abnormal than the normal dicot stem. Dicots with scattered vascular bundles as in Thalictrum. So there are some dicots like we have Thalictrum, then Podophyllum and Papaver, Somniferum. इसमें जो vascular bundles होते हैं वो scattered होते हैं, which is the feature of monocots basically, but they are dicots. So it is again an anomaly or abnormality. This is the photograph of Thalictrum, and it shows section. This photograph shows the sections of Thalictrum. Then this is Podophyllum, and it's a section of Podophyllum which shows scattered vascular bundles. Then comes the monocots with hollow internodes like we have wheat, grasses and tamus, which is the famous monocots example of family Dioscoriaceae. इसमें जो vascular bundles present होते हैं they are arranged in ring, और जो rings में vascular bundles होते हैं these are the main feature of dicots. Dicots में ring में present होते हैं, but these are some monocots. So exceptionally जो ये monocots हैं इनके hollow internode में present होते हैं vascular bundles in the shape of ring, or this is again an anomaly or anomalous growth. This is the photograph of this tamus, and it's a section of wheat which shows vascular bundles arranged in rings. Inverted vascular bundles in Rumex and Rheum of family Polygonaceae, which are again anomalous. Anomaly may occur in the primary as well as in the secondary state of stem. So जो anomaly है और abnormality है वो primary structure में भी present हो सकती है and it may be present. Next, anomalous secondary growth. Firstly, anomalous structures in dicot stem, then anomalous structures in monocot stem. So what are the various reasons for anomalous structures in monocot stem that we'll discuss firstly, formation of vascular cambium from outer region of ground tissue. So this is an anomalous growth, as we know that in case of monocots vascular bundles are closed type. It means जो इसमें cambium है वो absent होता है, but in some monocots जो vascular cambium है that arise from the outer region of ground tissue. Then formation of parenchyma towards outer side, as we know that this vascular cambium cuts secondary xylem towards inner side and secondary phloem towards outer side. But in case of these monocots इसमें जो vascular cambium है ये बाहर की तरफ को parenchyma बनाता है ज़्यादा, और vascular और जो secondary vascular tissues हैं वो अंदर की तरफ को बनाता है, which is again anomaly. Increase in girth without cambium. There are some monocots जिसमें जो girth है वो increase होती है but cambium absent होता है. For example, we have palms, musa and tulips. Then anomalous secondary growth in Boerhaavia, that we will discuss in detail, and this is the photograph of Boerhaavia diffusa, and it shows the medullary vascular bundle that we will discuss in detail. Then second, we have anomalous secondary growth in Dracaena stem. So these two topics are given in our syllabus that we will discuss in detail. So this is the photograph which shows Dracaena, which is a monocot, and it shows various vascular bundles and have multiple cambia. Next, anomalous structures in dicot stem. Firstly, we will discuss about the various reasons for anomalous secondary growth in case of dicot stem. So first reason is abnormal position with normal activity of cambium. So जो position है cambium की वो abnormal है, बल्कि जो activity है cambium की that is normal. So this is the first case which results in anomalous structures in dicots. So in some plants cambium is folded and these folds breaks, और ये जो folds हैं वो break हो जाते हैं जिससे जो cambium है वो separate हो जाता है एक दूसरे से, and each fold forms a complete vascular bundle, और एक जो fold है वो complete vascular bundle बनाता है. Here the activity of vascular cambium is normal, means it forms secondary phloem towards outer side and secondary xylem towards inner side. So many vascular bundles are formed as a result of this, and these type of vascular bundles are found in case of Thynovia, then Sergenia. This is the photograph which shows Sergenia, and this is the section of Sergenia which shows different vascular bundles, और ये होता है due to breakdown of that cambium strip. जो folded cambium strip है वो separate हो जाता है और it will form the complete vascular bundle. This is the photograph of Begonia purpurea. ये photograph show करता है Begonia purpurea को, and this plant is also known as camel toe tree because इसके जो leaves होते हैं its shape is just similar to that of camel toe, so that's why it is also known as camel toe tree. Next reason is abnormal activity of vascular cambium. So previously we have discussed abnormal position with normal activity of cambium. Here this is the abnormal activity of vascular cambium. In some plants parenchyma is formed from the maximum part of vascular cambium. So जो vascular cambium है इसके जो maximum part से parenchyma बनता है. Xylem and phloem are found rarely in some places, और जो xylem और phloem है they are vascular bundles वो बनते हैं rarely. So it is the anomalous nature or abnormal activity of vascular cambium. It is mostly found in case of the vines. जो vines हैं, it means lianas जो woody climbers हैं उनमें ऐसा पाया जाता है. Firstly we have Aristolochia. This is the photograph which shows Aristolochia. It is a climber. Then we have Vitis vinifera which is grapes. Vitis vinifera जो botanical name है grapes का. So ये जो climbers होते हैं woody climbers और जो normal climbers हैं herbaceous climbers, ये इनमें जो parenchymatous tissue है that provide flexibility to these vines, जिससे ये किसी support के surface के through climb करती हैं and grows. So most of the climbers they show anomalous secondary growth because they have abnormal activity of vascular cambium. This is the section of this Vitis vinifera. Next reason is successive rings of vascular cambium. successive rings of vascular cambium. In some plants, new rings of vascular cambium is formed after primary cambium ceases its function. So कुछ एक plants है जिनमें जो primary cambium है वो अपना function stop कर लेता है. It is taken up by the newly formed cambium. So new ring formed outside the previous ring. जो पहली ring है primary cambium की उसके बाहर एक नई ring बनती है and formed in the cortex and outer margins of the secondary phloem. और ये जो कैम्बियम बनता है ये बनता है या तो कॉर्टेक्स में या फिर आउटर मार्जिन ऑफ द सेकेंडरी फ्लोएम में. सो नंबर ऑफ वेस्कुलर बंडल्स अकर इन मेडुलरी रीजन. सो इसमें बहुत सारे वेस्कुलर बंडल्स मेडुलरी रीजन में प्रेजेंट होते हैं. फॉर एग्जांपल वी हैव मिराबिलिस jalapa, that is the 4 o'clock plant. This is a photograph of Mirabilis jalapa. Then we have this is the section of Mirabilis stem. इसमें जो वेस्कुलर बंडल्स हैं मेडुलरी रीजन में प्रेजेंट है, बाहर भी प्रेजेंट है. Then we have Boerhaavia diffuser that we have to study in detail. Then this is the section of Boerhaavia which shows anomalous secondary thickening. Then we have this photograph which shows the bougainvillea, which is also known as the garden's glory. This plant is also known as the garden's glory plant. It also shows. Next reason for anomalous secondary growth is formation of vascular cambium from pericycle. So there are some plants like we have members of family Amranthaceae and Podophyllum जिनमें जो primary cambium है उसकी activity stop हो जाती है थोड़े टाइम बाद, and some cells in pericycle region becomes meristematic and they form the cambium. और वो जो cambium से growth होती है secondary growth, that is anomalous or abnormal. So in plants of Amranthaceae and Podophyllum family, secondary growth due to activity of cambium in primary vascular bundle occurs for short periods. So जो secondary growth है in plants में due to the cambium which is already present, it occurs for a short period. After that its activity gets stopped. और ये जो photograph है, it is the photograph of Amaranthus which is a member of family Amranthaceae. It is used for making vegetables also. And this is the section of Amaranthus stem. It shows formation of cambium in the pericycle region. Pericycle region में cambium बनता है और इससे जो secondary growth होती है that is abnormal. A ring of cambium arises in the region of pericycle. इसमें जो pericycle का region है वहाँ पे cambium arise होता है, results in abnormal secondary growth or anomalous secondary growth. So again, this is the other reason for anomalous secondary growth, that is formation of vascular cambium from pericycle. Next comes interxylary cork. A cork layer develops between the two growth rings of secondary xylem, which is another reason for secondary anomalous secondary growth. तो जो दो rings हैं, growth rings हैं, उनके बीच में cork की layer develop होती है. For example, we have plants like we have Artemisia tridentata. So ये है प्लांट आर्टेमिसिया ट्राइडेंटला का. इसमें जो इंटरजाइलरी पोर्शन है, दो एनवल रिंग्स हैं, उनके बीच में कॉर्क की लेयर बनती है. एंड दिस इज अगेन एन anomalous secondary growth. नेक्स्ट कम्स फॉर्मेशन ऑफ कॉर्क कैम्बियम फ्रॉम एपिडर्मिस. सो इसमें जो एपिडर्मल सेल्स है दे विल गिव राइज टू द कॉर्क कैम्बियम. कॉर्क कैम्बियम ओरिजिनेट फ्रॉम एपिडर्मिस in plants like we have Malus pumila, that is apple. इसमें जो epidermal region है वहाँ से cork cambium बनता है. Then we have Solanum and Delcamara. This is a section of apple stem. Then we have Quercus super, which is commonly known as oak tree. So in plants में जो cork cambium बनता है it originates from epidermis. Next comes formation of cork cambium from pericycle. So there are some plants जिसमें pericycle से cork cambium बनता है. Not vascular cambium, it's cork cambium. So cork cambium originate from the pericycle in plants like we have one gymnosperm, that is Thuja. Then we have Clematis. This is Thuja occidentalis. It is mostly used for ornamental purposes or beautification purposes of the campuses. Then we have Clematis. और ये है Thuja का section. This is Clematis. इनमें जो कॉर्क कैम्बियम है वो बनता है फ्रॉम पेरिसाइकल सेल्स. नेक्स्ट कम्स फॉर्मेशन ऑफ कॉर्क कैम्बियम फ्रॉम फ्लोएम. फ्लोएम विल गिव राइज टू कॉर्क कैम्बियम, दैट इज अगेन एन एनोमैली और एबनॉर्मैलिटी. कॉर्क कैम्बियम इज डिराइव्ड फ्रॉम फ्लोएम. इसमें जो कॉर्क कैम्बियम है वो फ्लोएम से बनता है. इन प्लांट्स लाइक वी हैव विटिस जो कि एक वुडी क्लाइंबर है, और वुडी क्लाइंबर को कॉमनली कहा जाता है लियानास. टर्म यूज फॉर these plants are lianas, woody climbers like we have vitis and berberis. So this is the photograph of berberis. Next we will discuss Anomalous secondary growth in Boerhaavia stem in detail. So what TS of Boerhaavia stem shows, if we talk about its section, it is more or less circular in its outline. Outline में ये circular जैसा दिखता है with unicellular epidermis. It means it is made up of single cell thick epidermis, और उसमें कुछ स्टोमेटास भी प्रेजेंट होते हैं. Then it is followed by this epidermis is followed by hypodermis, which is made up of few layers of collenchyma. So ये जो hypodermis है वो collenchyma से बनती है. Then we have cortex. Cortex is composed of both collenchymatous cells as well as parenchymatous cells, और इनके बीच में प्रेजेंट होते हैं intercellular spaces. It means it consists of loosely arranged cells. Then it is followed by endodermis. It is single layer thick है ये, and is made up of many tubular thick word cells, और ये बनी होती है thick tubular cells से. Then it is followed by pericycle. Pericycle is made up of parenchymatous cells with isolated patches of sclerenchyma. So इसमें कुछ एक patches sclerenchyma के भी present होते हैं. This is the section which shows anomalous secondary growth. This is the text of normal secondary growth in case of Boerhaavia. Next, if we talk about these vascular bundles are conjoint, collateral, and dark, open, and occurs in 3 rings. और इसमें जो vascular bundles है वो 3 rings में present होते हैं. This is the first one, then second, and third ring. And dark means जो protoxylem है that faces toward the center or pith region. Open, having cambium in between the xylem and phloem. Collateral, it means जो xylem और phloem है they are in collateral position. Then we have conjoint. It means having a common radius. Then innermost ring possesses 2 large centrally placed medullary bundles that we can see here in this section. 2 center में बड़े large vascular bundles present होते हैं in the central region, which are known as medullary vascular bundles. Middle ring is with 6 to 14 loosely arranged bundles, और जो middle ring है इसमें होते हैं 6 to 14 vascular bundles. Outer third ring consists of 15 to 20 much smaller vascular bundles beneath the pericycle. So pericycle के नीचे vascular bundles होते हैं which forms the outer ring, और इसमें होते हैं 15 to 20 vascular bundles which lies beneath the pericycle. Then secondary growth in inner and middle rings is limited. जो inner और middle ring है वहाँ पे limited secondary growth होती है brought by fascicular cambium. Stem shows, if we talk about stem shows well-defined anomalous secondary growth in case of Boerhaavia, and characterized by the presence of successive rings of vascular cambium. So this is an anomaly. इसमें successive rings बनती है vascular cambium की. As we know that there are 3 rings of vascular bundles, तो 3 इसमें vascular rings भी बनती हैं vascular cambium की. So cambium consists of fusiform initials only. इसमें जो cambium है वो fusiform initials से बना होता है. That give rise to ray-less secondary vascular tissue. इसमें rays नहीं बनती हैं medullary rays, so it results in formation of ray-less secondary vascular. Next, during secondary growth, there is formation of interfascicular cambium. So this is the cambium which is formed between 2 vascular bundles. जो vascular bundles हैं 2, उनके बीच में जब कुछ parenchymatous cells they become meristematic, they form this interfascicular cambium. और जो vascular bundle के अंदर cambium होता है उसे कहते हैं fascicular cambium. So this secondary growth begins with the formation of cambium strip in the interfascicular region in the outer ring of vascular bundles. जो outer ring है vascular bundles में वहाँ पे एक complete ring बनती है vascular cambium की, जो बनाती है secondary vascular tissue in the fascicular region. जो vascular bundle का fascicular region वहाँ पे, और जो interfascicular region है वहाँ पे बनता है tissue जिसे बोलते हैं conjunctive tissue, which is thick wall tissue. So these interfascicular cambium along with fascicular cambium forms a complete ring of vascular cambium. So एक complete ring बनती है vascular cambium की, जिसे cambium ring कहते हैं. It produces secondary xylem and secondary phloem in the fascicular region, that is xylem towards the inner side, और जो phloem है बाहर की तरफ बनता है in the fascicular region, और इन बिटवीन दिस इंटरफेसिकुलर रीजन यहाँ पे बनता है कंजक्टिव टिश्यू, and in the fascicular region it will form the secondary xylem, secondary phloem, while lignified conjunctive tissue is formed in the interfascicular region. जो interfascicular region है वहाँ पे बनता है lignified conjunctive tissue. So the activity of this continues for some time. जो कैम्बियम की एक्टिविटी थोड़े टाइम के लिए रहती है, then it stops or ceases. कुछ नए कैम्बियम स्ट्रिप्स बनते हैं जो डेवलप होते हैं फ्रॉम द पैरेन्काइमटस सेल्स प्रोड्यूस्ड बाय फर्स्ट कैम्बियम रिंग. जो पहली कैम्बियम रिंग है वो कुछ एक पैरेन्काइमटस सेल्स भी बनाती है टुवर्ड्स द आउटर साइड, और उससे बनती है नई कैम्बियम रिंग. दीज स्ट्रिप्स फॉर्म्ड इन द इंटरफेसिकुलर रीजन, और ये बनती है इंटरफेसिकुलर रीजन्स में, मीन्स दो वेस्कुलर बंडल्स के बीच में. These cambium strips then joined with extrafascicular cambium. एक extrafascicular cambium बनता है. Extra means जो vascular bundles के बीच में नहीं होता. It is formed from pericycle cells. So pericycle के कुछ cells और जो ये parenchymatous के cells है जो meristematic होते हैं, they form a complete ring. So cambium is formed from the pericycle. This extrafascicular cambium is formed from pericycle. Both extrafascicular cambium and interfascicular cambium joins to form second ring of cambium. ये दोनों ही join करते हैं जिससे second ring बनती है cambium की. The activity of this cambium is same as that of the first cambium. जो पहली cambium थी उसी की तरह इसकी activity है. As soon its activity also ceases or stop होती है, and new cambium ring is formed in the similar way. और एक नई cambium ring बनेगी. Simultaneously जो secondary growth होती है that also occur in the middle ring and inner ring of medullary vascular bundles. जो middle ring है और inner ring है vascular bundles के, उनमें भी secondary growth होती है simultaneously, but this secondary growth is confined to within the vascular bundle only. तो ये जो secondary growth होती है सिर्फ vascular bundle तक ही confined होती है. The outer protective covering is formed by the activity of cork cambium, which is developed in the hypodermal region. It forms the periderm. As we know that normally जो cork cambium है that वो बाहर की तरफ को बनाता है कॉर्क, जिसको फैलम भी कहते हैं, और अंदर की तरफ को ये बनाता है सेकेंडरी कॉर्टेक्स. एंड दीज थ्री लेयर्स कंबाइंस टू फॉर्म दिस पेरीडर्म, जो कि एक प्रोटेक्टिव लेयर है. तो इसमें जो हाइपोडर्मल के सेल्स हैं दे बिकम्स मेरिस्टेमेटिक एंड फॉर्म्स द कॉर्क कैम्बियम, जो बाहर की तरफ को कॉर्क बनाता है और अंदर की तरफ को सेकेंडरी कॉर्टेक्स. Next comes anomalous secondary growth in Dracaena, which is a monocot stem. If we talk about its primary structure, जो primary stem है, जो young stem है, उसके stem के structure की बात करें, so it shows single layer epidermis covered with cuticle. Then it contains ground tissue, जो बना होता है parenchymatous tissue से, parenchymatous cells से, and contains numerous conjoint, collateral and dark and closed primary vascular bundles जो scattered होते हैं ground tissue. And each vascular bundle is enclosed by a bundle sheath, और हर एक vascular bundle के बाहर present होती है sclerenchymatous bundle sheath. So this is all about the primary structure of Dracaena stem, which is similar to that of other monocots. And this is the photograph which shows Dracaena plant. Next, secondary growth, that is anomalous. In case of Dracaena, as we know that in monocots cambium is absent, but this Dracaena shows the presence of cambium, which is anomaly or abnormality. So secondary growth is initiated by parenchymatous cells of ground tissue outside the primary vascular bundle. जो primary vascular bundles हैं उनके बाहर कुछ cells, they becomes meristematic. ये meristematic हो जाते हैं. These cells becomes meristematic means they regain their power of cell division, develops anomalous secondary, anomalous cambium, और ये बनाते हैं anomalous cambium which divides by tangential divisions. और ये जो cambium बनता है ये divide करता है tangential divisions से. This cambium does not produce secondary tissue. ये secondary tissue produce नहीं करता है. Instead, it divides mostly by tangential divisions, and new cells are arranged radially. और नए cells बनते हैं radially. Initially divide करते हैं और नए cells add होते हैं radially, and produces more tissue towards the inner side. जो ये meristematic cells हैं ये divide होते हैं और ज़्यादा cells add करते हैं inner side में, then towards outer side. These cells initially remains meristematic. Initially ये सभी cells meristematic होते हैं. Later on कुछ cells meristematic रहते हैं. There remains some cells or few cells remains meristematic, and rest of the other cells gets differentiated into parenchymatous cells. और जो maximum cells हैं वो differentiate हो जाते हैं parenchymatous cells. और जो parenchyma that forms the conjunctive tissue, और ये parenchyma बनाता है conjunctive tissue. जिसमें कि वेस्कुलर बंडल्स लाई करते हैं। सो पैरेन्काइमा इनर टू कैम्बियम, कैम्बियम के अंदर वाला जो पैरेन्काइमा दैट डेवलप्स पार्टली इनटू कंजक्टिव टिश्यू, सब का सब पैरेन्काइमा कन्वर्ट नहीं होता है कंजक्टिव में, सम ऑफ द पैरेन्काइमेटस टिश्यू गेट्स कन्वर्टेड इनटू द कंजक्टिव टिश्यू। नेक्स्ट फ्यू मेरिस्टेमेटिक सेल्स डेवलप्स इनटू द सेकेंडरी वेस्कुलर टिश्यू, जो कुछ मेरिस्टेमेटिक सेल्स थे वो डेवलप होते हैं इनटू सेकेंडरी वेस्कुलर टिश्यू, एंड फ्यू सेल्स इन द सेंटर गेट्स डिफरेंशिएटेड इनटू फ्लोएम। सेंटर के कुछ एक सेल्स वो डिफरेंशिएट होते हैं फ्लोएम में और दे आर सराउंडेड बाय द जाइलम सेल, और जो पेरिफेरल सेल्स है दे गेट्स डिफरेंशिएटेड इनटू जाइलम। और इस तरह के वेस्कुलर बंडल जिसमें सेंटर में फ्लोएम प्रेजेंट होता है विच आर सराउंडेड बाय जाइलम, ऐसे वेस्कुलर बंडल्स को बोलते हैं एम्फी वेसल टाइप ऑफ वेस्कुलर बंडल्स, known as the amphi-vessel type of vascular bundles. So these vascular bundles are secondary in origin. ये secondary vascular bundles हैं, and this called secondary vascular bundles. These remains embedded in the parenchymatous conjunctive tissue, और ये conjunctive tissue में embedded होते हैं. And the secondary vascular bundles here found are known as amphi-vessel and concentric type of vascular bundles and are oval in shape, और इनकी shape होती है oval. Phloem consists of seed tubes, companion cells, and parenchyma, while xylem consists of tracheids with scleriform thickening, which means ladder-like thickening, and small amount of xylem parenchyma. So this is the composition of phloem and xylem in Dracaena stem. Next comes formation of protective layer, that is cork. So cells in the deeper region of cortex divides periclinally. It means they add the number of layers. Periclinal division से ये जो कॉर्टेक्स के सेल डिवाइड करते हैं टू फॉर्म प्रोड्यूस स्टोरिड मेरिस्टेम, और उससे बनता है मेरिस्टेम, डिफरेंट लेयर ऑफ मेरिस्टेमेटिक सेल्स जिसे बोलते हैं स्टोरिड कैम्बियम और स्टोरिड मेरिस्टेम। देन सीरीज ऑफ सेल्स फॉर्म्ड अंडरगो सुपराइजेशन, जो इसके डिवीजन से सेल्स बनते हैं दे गेट सुपराइज्ड, बाहर से सुपरिन की कवरिंग इसमें ऐड हो जाती है, एंड दे गेट्स डिफरेंशिएटेड टू कॉर्क सेल्स, बाहर की तरफ को ये बनाते हैं कॉर्क सेल्स, एंड दिस टिश्यू इज नोन एज स्टोरिड कॉर्क, और इसको बोलते हैं स्टोरिड कॉर्क। In case of aloe vera, coconut and royal palm, the periderm is formed in the same manner as in dicots. So dicots के केस में जो कॉर्क कैम्बियम है ये बाहर की तरफ को बनाता है कॉर्क और अंदर की तरफ को बनाता है सेकेंडरी कॉर्टेक्स, और ये तीनों लेयर्स मिलकर बनाती है पेरिडर्म, which is similar to that of dicots. So ये कुछ प्लांट्स हैं लाइक वी हैव aloe vera, coconut and royal palm, इनमें भी पेरिडर्म इसी तरह से बनती है जैसे कि डाइकोट्स में बनती है। Next comes secondary growth in roots. Secondary growth occurs in the roots of gymnosperms and dicotyledons. कुछ एक dicots हैं और gymnosperms हैं, उनकी roots में secondary growth होती है, and dicot roots have radial vascular bundles with exact xylem, which is the unique feature of roots. Roots में radial vascular bundle present होते हैं और exact xylem, it means जो protoxylem है that faces towards the peripheral region, or we can say pericycle. Secondary growth is initiated by activity of vascular cambium. Few cells beneath each group of phloem becomes meristematic. Phloem के नीचे कुछ एक cells meristematic बनते हैं, and thus forms as many cambial strips as the number of phloem. जो जितने phloem present है उतने ही यहाँ पे cambium बनते हैं। Cambial cell divide tangentially again and again and produces secondary tissue. जो cambium cells हैं वो divide करते हैं to form the secondary cells of the pericycle outside the protoxylem group becomes meristematic and divides to form few layers. कुछ सेल जो पेरिसाइकिल के सेल्स हैं जो प्रेजेंट होते हैं प्रोटोजाइलम के जस्ट आउटसाइड, वो भी अपनी पावर ऑफ सेल डिवीजन रिगेन करते हैं, they become meristematic and divide to form few layers of cells. Then complete circular ring of cambium is formed by joining of the cambium in the pericycle with the cambial strips of phloem tissue. As we have discussed, जो phloem है phloem tissue के नीचे भी cambium strips बनती हैं और साथ में pericycle में बनती हैं, तो ये जो strips हैं ये join करते हैं एक दूसरे को, they form a complete ring of cambium, एक complete ring बनती है cambium की. It produces secondary xylem on the inner side and secondary phloem towards the outer side, which is the normal secondary growth. Then cambial cells formed from pericycle give rise to medullary rays. जो cambium cells बने हैं पेरिसाइकल से वो बनाते हैं मेडुलरी रेज, और जो फ्लोएम से के नीचे वाले सेल्स हैं जिससे कैम्बियम बना, दे विल फॉर्म द सेकेंडरी वेस्कुलर टिश्यू, दैट इज सेकेंडरी फ्लोएम टुवर्ड्स आउटर साइड एंड सेकेंडरी xylem टुवर्ड्स द इनर साइड. Secondary xylem and secondary phloem increases in thickness ड्यू टू सेकेंडरी ग्रोथ ये थिकनेस में इंक्रीज होते हैं, रप्चर द कॉर्टेक्स विद एंडोडर्मिस, जो एंडोडर्मिस है और कॉर्टेक्स है वो रप्चर हो जाती है। दैन पेरिडर्म इज प्रोड्यूस्ड टू एज प्रोटेक्टिव लेयर, पेरिडर्म बनती है इसमें। पेरिडर्म इज फॉर्म्ड बाय द कॉर्क कैम्बियम, जो कि बाहर की तरफ को कॉर्क और अंदर की तरफ को सेकेंडरी जाइलम बनाता है। दीज थ्री लेयर्स कंबाइन टू फॉर्म द पेरिडर्म। पेरीसाइकिल बिकम्स मेरिस्टेमेटिक एंड डिवाइड्स टू फॉर्म कॉर्क कैम्बियम, जो कॉर्क कैम्बियम है वो भी पेरीसाइकिल से बनता है। एंड इट विल गिव राइज टू द कॉर्क टुवर्ड्स आउटर साइड, और अंदर की तरफ को कुछ पैरेन्काइमल सेल्स। This was all about for our today discussion about anomalous secondary growth in dicot stem, that is Boerhaavia, and monocot stem, that is Dracaena. Hope you will get some idea from this presentation. If you have any questions, queries, and any suggestions, you can give it in the comment section. Thanks for watching. Have a great day.